All right, so let's talk about properties of logs and solving logarithmic equations. We've been talking about logs for a little bit, the inverse of exponents. So we can use properties of exponents to develop the properties for logarithms since they're the inverse. And so we have three main properties that we worry about. The product property, the quotient property, and the power property. So for the product property, for all positive numbers a, b, and x, where x does not equal 1, log x of a times b, right? So log of base x of a times b equals log base x of a plus log base x of b. And this should kind of make sense because when we add exponents, we're talking about multiplying their bases. Okay, so let's look at the quotient property. For all positive numbers a, b, and x, where x is not equal to 1, the log of base x of a divided by b equals the log of base x of a minus the log of base x of b. And finally, the power property. And this one's a really cool one. So the power property of logarithms for any real number p and positive numbers m and b, where b does not equal 1, log of base b of m to the p equals p times the log of base b m. And so what you notice here is that this exponent up here, if m is raised to an exponent, we can just bring that exponent down and make it a factor, and it's really powerful and lets us solve a lot of really cool things. All right, so a bunch of examples. So use the knowledge that log base 3 of 28 is approximately this number, and log base 3 of 4 is approximately this. And so let's use those to approximate the value of each of these expressions. So if we have log base 3 of 36, that equals this. And we kind of broke up 36 into numbers that we're looking for, right? So we like the log of 28 and we like the log of 4, all right? So we broke those up into numbers we can deal with. And so now we have these two things. And so we can break the product up into a sum using the product property. And so then now we can do a couple of things. We can use the power property to bring this 2 down in front. Okay, we take the exponent out and bring that 2 down in front. Now this is special right here. Okay, this is 3 to something equals 3. Well, that is always going to equal 1, right? Because any log with the same numbers here, right? The power 3 to what power equals 3? Well, it's always going to be 1. So that's an identity. And then we just evaluate these two things, right? So 2 times 1 is 2, and this was given to us up here. And so we get our answer is approximately 3.2619. And you'll see that it's approximate because this actually would go on probably forever. All right, another example. So we have the same numbers that we're going to use. We know those two values, so those are our goal. How can we do this when we have log of 7? Well, we could rewrite log of 7, log base 3 of 7 as 28 divided by 4. All right, so now we can break this quotient into a subtraction problem, right? That's the quotient rule, the quotient property. And so now we already know that these two things have these two values, so we can replace them, and we get our final answer of approximately 1.7712. All right, how about this one? So we are given log base 3 of 256, and we can write 256 as 4 to the 4th. And so our product property says that we can bring that exponent to the front, make it a factor, and multiply the log base 3 of 4 times 4. And so now we can just replace what we have, and we get approximately 5.0476, right? So this number here and these numbers are coming from things we're given, right? And you could put this in your calculator if you have beyond a TI-83, if you have a TI-83 plus or TI-84 or TI-86, you can actually plug these in. We will talk about how to do these bases if you don't have a more advanced calculator. All right, so we can use these to solve problems involving logarithms. So let's see. If we have 2 times log base 3 of x minus log base 3, 4, right, we can rewrite that as log base 3. So we can't rewrite that, sorry. We can, and we're told that it equals log base 3 of 25. We can use properties to actually find x. All right, so this is what we start with. And so we can go backwards, right? This is the product property, because if we have a 2 in front, we can say, hey, that is an exponent. And I said product, but I meant power. Okay, it's the power property, right? Because we had a coefficient, and we can make it our exponent, right? And then so now we can combine this subtraction. They have the same base, and so subtraction was the quotient property. So now we can say, okay, x squared divided by 4 is the same as what we have up here. You notice we've left this alone. We haven't touched this yet. And so notice we can rewrite this as x squared divided by 4 equals 25. And so this is kind of long. So it's the property of equality for log functions, right? If I have log of base 3 of this and log base 3 of this, that means these two things have to equal each other if this is equal. Now, I'm showing you I'm writing what I'm doing every time, just so you hear it and think about it and understand it. You can write this down as you go if you want. It's great, but I'm not expecting you to. So now we can solve this. All right, so what did I do to both sides? I multiplied both sides by 4, and then I square root both sides, and so I get plus or minus 10. Now, let's talk about one more thing. Since logarithms are undefined when x is less than 0, right? Logarithms are undefined when x is less than 0. I can't raise an exponent to raise a base to anything that will give me a negative answer. That just doesn't work. Negative exponents just give me fractions, right? So this tells me that negative 10 is extraneous solution. So only 10 is a solution. And so just so we understand extraneous solution, sometimes we get an extra answer that does not make sense or doesn't work. We call this extraneous, right? All right, so here's this problem, log base 2 of x minus log base 2 of x plus 2. And so I have parentheses here, and that equals 3. So our original equation. And so we can really quickly see that we can rewrite this. And we use the product property. Right, and so we can say that these two products, the x times x plus 2 equals 2 to the third, right? And why did we do that? Well, so this is definition of a logarithm. Okay, because what we're saying here is that we have log base 2 of this product equals 3. So we're saying 2 raised to the third power equals this. And that's what we've written down here. 2 to the third equals this. All right. And so x squared plus 2x, because I distributed, equals 8. And now I can solve and make it a quadratic. So I subtracted 8 from both sides, and I factor it, and I end up with x equals 2 or x equals negative 4, right? That's the zero product property. And we have an extraneous solution again, right? Negative 4 can't be an answer. It can't be a solution because x cannot be less than